Hello students, welcome to another session of this integration. In this session, we will be dealing with integration using trigonometric identities. So it is very essential for everyone while evaluating integration, you must have the ideas of all trigonometric identities. So I will be doing one by one. See here, as you know, sin square x plus cos square x is very first trigonometric identity. This can be used. If you transfer this cos square this side, you will get new relation, that is sin square x can be written as 1 minus cos square. Similarly, if you transfer this sin square this side, so cos square equals to 1 minus sin square. Now see here, you also studied 1 plus tan square x is equals to secant square x. So its modified form tan square x is equals to secant square x minus 1. Okay, so whenever tan square comes under the integral sign, you have to replace it by secant square x minus 1. Okay, so for example, see here, suppose if you come across this integration of tan square x dx, then immediately you have to write it as integration of tan square means secant square x minus 1 dx, which is equals to integration of secant square is known to you. This is the derivative of tan. Adike, you can write directly it as tan x minus 1 plus c. Similarly, suppose if you get situation like this, tan square 3x dx. So you have to write it as secant square 3x minus 1 plus into dx. So integration of secant square 3x, as we discussed, it is tan 3x by 3 minus integration of 1 is x plus c. Okay, integration of sec square ax is tan ax by a. So here a is 3. Similarly, suppose this is your fifth one. You also know that 1 plus cot square x. 1 plus cot square x is cosec square x. And this gives you cot square is equals to cosec square x minus 1. Okay, so you have to remember this. Okay, whenever under the integral sign, if cot square comes, immediately you have to replace it as cosec square minus 1. So look at this. Suppose this is the example of integrating cot square x. So cot square is not the derivative of any standard function, so you have to replace it by this integration of cosec square x minus 1 into dx, which is equals to integration of cosec square is minus cot x minus integration of 1 is x plus c. Similarly, if you get a situation like this, integration of cot square 2x dx, similarly you can express it as cot square means cosec square x minus, that is cosec square 2x minus 1 into dx, which is equals to integration of cosec square is minus cot, but we have 2x here, so you have to write cos 2x by 2 minus integration of 1 is x plus c. Okay, so sixth one, we have this cos 2x. Cos 2x is actually 2 cos square x minus 1. And from this, what is 2 cos square x? 2 cos square x is, if you bring it this side, 1 plus cos 2x you will get. This minus 1 becomes plus 1. So 1 plus cos 2x. So this gives you cos square x is equals to 1 plus cos 2x by 2. See here. So if you want convert cos square as a sum of two terms without square, then you can make use of it. Cos square x can be written as 1 plus cos 2x by 2. Whatever this angle, it gets doubled here. Suppose if you are 2x here, it becomes 1 plus cos 4x by 2. Okay, so as the time requires, as the function demands under the integral sign, we make these substitutions. Okay, so sometimes 1 plus cos 2x has to be replaced by 2 cos square x. Similarly, both are important here. Okay, so here both of these, this as well as this, you have to remember this. 1 plus cos 2x means 2 cos square x. Suppose if we have 1 plus cos x, it is x by 2, 2 cos square x by 2. So remember this also, I will be writing because sometimes I require this. This can be written as 1 plus cos 2x can also be, 1 plus cos x can also be replaced as 2 cos square x by 2. Okay. Let's have next, that is cos 2x, another form of cos 2x. Another form of cos 2x is cos 2x can also be written in terms of sign. Cos 2x is, it is 1 minus 2 sine square x, that is known to you, I suppose. So from this, 2 sine square x is 1 minus cos 2x. So sine square x can be written as, it is 1 minus cos 2x by 2. And also you have to remember what this implies. 1 minus cos 2x is this much, and if you require 1 minus cos x, it can be replaced as 2 sine square x by 2. So see how these can be used. Suppose if you come across the situation like this, 1 minus cos 2x by 1 plus cos dx. If you want to integrate this, so you make use of the previous results. Look here, 1 minus cos 2x can be written as 2 sine square x. So it is 2 sine square x divided by 2 cos square x. 1 plus cos 2x is, in the previous page, 1 plus cos 2x is 2 cos square x. So 2 cancels. Sine square by cos square means tan square. And I told you how tan square can be integrated. Tan square means you have to replace it by secant square x minus 1 dx. Tan square is secant square x minus 1. So now you can integrate. Integration of this is, integration of sec square is tan x. Integration of 1 is x plus c. Let's have another example. Suppose if you come across this, integrating 1 plus cos x by 1 minus cos x dx. Okay. Now see here, 1 plus cos x. See here, 1 plus cos 2x means 2 cos square x. 2x gets half. So similarly, 1 plus cos means it is 2 cos square x by 2 divided by 1 minus cos means 2 sin square x by 2. I mentioned earlier. Look at this. 1 minus cos x means 2 sin square x by 2. Okay. So as earlier, 2 get cancels. You will get this 2 to cancels, cos square by sin square. That gives you cot square x, and which is equals to cot square. You have to write it as cosec square x minus 1, as I mentioned earlier. So this is equals to integration of cosec square is minus cot x, integration of 1 is x plus c. So let's have another example. For example, suppose if you are asked we'll be doing 7.3 exercise. Okay. Find the integrals of, first one is sine square 2x plus 5. Okay. So let us I is equals to integration of sine square 2x plus 5 dx. Okay. So there is no standard integral for direct sine square. Okay. So you need to convert this. You need to use this. As I mentioned earlier, sine square x is, it's a 1 minus cos 2x by 2. Sine square x is 1 minus cos 2x by 2, that we discussed in the last page. Okay, so this sine square can be written as 1 minus cos of 2 into this 2x plus 5 divided by 2 into dx. Okay, 1 by 2 outside, integration of 1 minus cos 2 into 2 4x plus 5 dx. Okay, now this is equals to 1 by 2 integration of 1 is x minus integration of cos ax or ax plus b gives you sine ax plus b divided by a. Coefficient of x is 4 here. That you have studied, I suppose. Remember this, integration of cos ax plus b is sine ax plus b whole divided by a. Okay, so coefficient of x you have to write down. So this is how you can use the trigonometric identity. Please note on this, sine square x is 1 minus cos 2x by 2. Okay, so angle of this gets doubled here. Now see here, suppose if we get same format, suppose if we get no, okay, let me do first complete exercise, otherwise this is your example. Suppose if you come across this integration of cos square x dx, so cos square can be written as it is 1 plus cos 2x by 2. I had given you cos square x means 1 plus cos 2x by 2. So 1 by 2 outside, integration of 1 plus cos 2x dx. So this gives you 1 by 2, integration of 1 is x, integration of cos, as I mentioned earlier, cos ax is sine ax by a. That a means 2 here, plus c. Okay, so this is your worked example. So go through this. Okay, let's have an example of exercise 7.3. 7.3 example 2. You are asked to integrate this. Integrate sine 3x into sine 4x. Okay, so we'll integrate this sine 3x into sine 4x. Now see here, your I is, it is integration sine 3x into sine 4x dx. So one thing to be noted, all these transformation formulas. So please note down this and then we will evaluate this. So transformation formulae. So these are used to convert product into sum. Under the integral sign, if you get product of sine cos, sine cos cos, you make them as a sum. So please note down this. Sine A cos B. Suppose if we get this sine A into cos B, this can be written as 1 by 2 sine a plus b plus sine a minus b. Okay, sine into cos. Suppose you have this cos a into sine b. Cos a into sine b. You have to write it is 1 by 2 sine a plus b minus sine a minus b. Suppose if you come across this cos a into cos b, 1 by 2 it is cos a plus b plus cos a minus b. Cos a minus b. Okay. Last one, sine a into sine b. Suppose if you get sine a into sine b, it is minus 1 by 2 cos of a plus b minus cos of a minus b. Either you can use this, or if you take this minus inside, this term becomes plus and this term becomes minus. Okay, so you can use alternate form of this is, if you take minus inside, so 1 by 2 cos of a minus b, this term becomes first, minus cos of a plus b. Okay, so please do remember these transformation formulas. These play very important role while integrating the product of sine and cos, or cos and cos. So in the given example, okay, so what we had, this was our case, sine 3x into cos 4x. So we had this integrating sine 3x into cos 4x. Okay, now this resembles the formula is sine a into cos b, so use that. It's a 1 by 2 sine of a plus b, that is 3x plus 4x, plus sine of a minus b, sine of 3x minus 4x dx. Okay, if you look at this, you are given, so our given is, so make some correction here. Okay, this is your textbook example. This is example sine 3x into cos 4x. Okay, so this is equals to 1 by 2 outside. This is sine 7x plus sine of minus x you will get. Okay, so this is 3x minus 4x is minus x. 1 by 2 integration of sine 7x, sine of minus theta is minus sine theta, so you can write minus sine x. Okay, because that you know sine of minus theta is minus sine theta. Okay, now you can integrate very easily. 1 by 2 integration of sine ax, I told you it is minus cos ax, that is 7x by 7, minus integration of sine is minus cos, and plus constant c. So which is equals to 1 by 2 minus cos 7x by 7 plus cos x plus c. Okay, so in this way, if we get under the integral sign product of sines or sine into cos, you have to convert it as a sum. Let me write one example for your practice. Okay, suppose you come across this. Evaluate integration sine or cos 3x into cos 2x dx. Suppose if you want to integrate cos into cos, now you can use the formula cos A cos B. Let me write it. What is cos A cos B? Cos A cos B is 1 by 2 cos of A plus B plus cos of A minus B. Okay, so I had given you, so use that. So 1 by 2, one can write directly cos A plus B, that is 3x plus 2x is 5x, that is cos 5x plus cos of A minus B, 3x minus 2x is 1x dx. So 1 by 2 as it is. Now you can write directly what is the integration of cos ax. It is sin ax, that is 5x by sin 5x by 5 plus integration of cos x is sin x plus c. Okay, so similar example. Suppose if you come across this integration of sin x into sin 2x. Okay, now here use the result sin A into sin B. Sin A into sin B is modified, it's a 1 by 2. First you have to write cos of A minus B minus of cos of A plus B. I had given you earlier. Okay, sin A into sin B is 1 by 2 cos of A minus B minus cos A plus B. So you can write it as 1 by 2 cos of A minus B cos of x minus 2x minus cos of A plus B x plus 2x into dx. It's a 1 by 2 integration of cos of minus x. You will get x minus 2x is cos of minus x. It's a cos of x plus 2x is 3x dx. So 1 by 2 cos of minus theta is cos theta only. So I can write only cos x. Cos of minus x is cos x. This is cos of 3x dx. Remember this because cos of minus theta is cos theta. If you get sine here, sine of minus theta is minus comes outside. Now you can write what is the integration of sine is. Integration of cos is sin x. Integration of cos ax, that is sin ax by a. So that is sin 3x by 3 plus c. So in this way you can evaluate the integrals with product of sine and cos. Okay. Now here is one example. Exercise number 7.3. Example number 3. Okay, 7.3 exercise problem number 3. You are asked to evaluate this. Integrate. You are asked to evaluate this cos 2x into cos 4x into cos 6x dx. Okay, product of cos cos cos. Okay, what you need to do is you rearrange them, means take product of two terms as a one factor and other as it is. So better you write cos 6x cos 4x into cos 2x dx. Okay, so I prefer writing in this order. Okay, bigger angles first, means that avoid confusion in signs. Okay, now cos 6x as it is, you have to use the formula for cos a cos b. Cos a cos b is 1 by 2. What is cos a into cos b? It's a 1 by 2 cos of a plus b, that is cos of 4x plus 2x. One can write it directly 6x plus cos of 4x minus 2x into dx. Okay, remember the formula for cos a cos b. Cos a cos b is 1 by 2 cos a plus b plus cos a minus b. Okay, this 1 by 2 outside, integration of cos 6x into, okay, this gives you cos 6x plus 4x minus 2x gives you cos 2x into dx. 1 by 2 integration, get multiply this cos 6x into cos 6x. Either you can write cos square 6x, and if you know the formula for cos square you can use that. Otherwise, if you don't know that, then keep it as cos 6x into cos 6x. Okay, so cos square 6x plus cos 6x into cos 2x. Okay, so those who knows the formula for cos square, they can use it. Otherwise, you can write like cos 6x into cos 6x, same way as it is. Now you have to use cos a cos b formula. Okay, so first cos square 6x, that I mentioned earlier, cos square theta. Cos square x is 1 by 2 1 plus cos 2x. Remember this. If you know this, you can use this. Otherwise, you can write cos into cos. Okay, so it is how much? It is 1 by 2 1 plus cos double of this. ನೋಡಿ ಇಲ್ಲಿ x ಇದ್ರೆ 2x ಇದೆ, ಇಲ್ಲಿ 6x ಇದ್ರೆ 12x ಆಗುತ್ತೆ, ಪ್ಲಸ್ ಇಲ್ಲಿ cos a into cos b ಫಾರ್ಮುಲಾ 1 by 2. okay, cos a into cos b is 1 by 2 cos a plus b. Cos a plus b is 8x plus cos a minus b, that is 6x minus 2x is 4x. Remember this. Okay, this is equals to, taking 1 by 2 outside, already 1 by 2 is there, so 1 by 2 into 1 by 2 integration of 1 plus cos 12x plus cos 8x plus cos 4x. Okay, now you can integrate 1 by 2 into 1 by 2 is 1 by 4. Integration means I will integrate now directly right now. Integration of 1 is x, integration of cos 12x is sin 12x by 12 plus integration of cos 8x is sin 8x by 8 and plus it is sin 4x by 4 plus constant c. In this way, if you get product of three terms, twice you need to use the transformation formula. Okay, so So let's have another example of the same kind. This is example number 6. This is example number 6. You are asked to evaluate this. Integrate sin x into sin 2x into sin 3x. Okay. Now, as I said earlier, you need to make regroup it. First I write sin 3x into sin 2x in the decreasing order of the angle I write. Okay. Dx. Okay. Now see here, you need to use this sin A sin B formula. Okay. So sin A into sin B I have written earlier. So you need to use this. What is sin A into sin B? It is 1 by 2 cos of A minus B. Remember this. Minus cos of A plus B. Okay. So what you will get? You will get 1 by 2 into, okay, cos of A minus B, that is 2x minus x. I will write x minus cos of A plus B, 2x plus x is 3x into dx. Without this transformation formula, it is impossible, you may go wrong. So 1 by 2 outside, get multiply sin 3x into cos x as the one term minus sin 3x into cos 3x. Okay. Now you have to use this sin A into cos B. Use sin A into cos B. Sin A into cos B is 1 by 2 sin of A plus B plus sin of A minus B. Okay. So what will get? 1 by 2 as it is under the integral sign. For this, it is 1 by 2 sin of A plus B. 3x plus x is 4x plus sin of A minus B. 3x minus x is 2x. So it is sin of 2x. Similarly for this, okay, for this 1 by 2 outside, 3x plus 3x, that is sin of 6x plus 3x minus 3x, you will get 0. So sin of 0 you will get into dx. Okay. So 1 by 2 common is here. So you can take 1 by 2 outside. So already 1 by 2 is there. So right remaining, it is sin 4x plus sin 2x minus sin 6x, and sin 0 is 0. Okay. So sin 0 is 0. Right, because sin 0 is 0. Yeah. Now 1 by 4. Now go on writing the integration. Integration of sin ax. Integration of sin ax is minus cos ax by a. That is minus cos 4x by 4. Minus cos. Integration of sin is minus cos 2x by 2. Minus of minus, it becomes plus cos of 6x by 6 plus c. Okay, so please note down this: integration of sine ax is minus cos ax by a. Okay, whatever this number comes down. So remember this and practice this. I will be giving one example for your exercise. Please try this. Yes. Please work these examples so as to perfect. Evaluate integration cos 4x into sine 2x sin x into cos 3x into sin 5x dx. My intention is to make perfect u-win using transformation formula. So please work these two examples. Okay. Now let's. Okay, so in this session, I suppose this much is enough. So in the next session, we will be dealing with few more identities. Okay, so take care and keep watching.